No. So we will have a separate. It's. Am I wrong on time? No, I think so. Okay, so we're starting again with a free presentation about XSL, copy fitting, upward projection, splitting document, and so on. So Gerrit will present us a few things, especially related to dishwasher, I think. That's mostly his trademark now. Everyone has a trademark in this conference. This is yours. And please.
Yeah, so I need to ask for apologies in advance. Just like last year, I just finished my slides at the last minute, and again wasn't even able to rehearse, but never mind. Well, it's about or what. Maybe I shouldn't submit papers to XMLPrague anymore because it's always so stressful. On the other hand, what triggered me to submit something was late November last year when I saw a video of DITA OT Day where Elliot Kimber presented a splitting solution that I, developed for him last year. And in his presentation, he said he doesn't fully understand the solution, and therefore I thought it's maybe a good idea because it's a quite universal solution for splitting XML to present it in this context here. So let's look at the applications that I will cover. One scenario is we have a TEI file with page break elements, the PB empty tags, and you want to generate a TEI file, a distinct TEI file for each page. And the problem is that the page breaks can be nested at an arbitrary depth in the XML. So this is problematic. You don't have neatly separated sections or something like that. Then there's Elliot Kimber's problem. He had alternating single column and two column ranges in an XSLFO, and the problem is that the markers for switching from single column to two column are also deeply embedded in some FO output, and it needs to be split at these locations so that there's an outer block for single column, an outer block for double column, and so on. And finally, another application is when you want to split paragraphs at line breaks. You need to consider that the paragraphs in DocBook, for example, may contain lists or footnotes, and these in turn can, again, contain paragraphs, possibly with line breaks. I mean, in DocBook, there are no actual line break elements, but people misuse phrase role equals BR maybe for these purposes, so there are actually line breaks. And it's problematic if you split the paragraph at each line break at arbitrary depth, then you will split the footnote that is contained in the paragraph also in two because it's, contained in the outermost paragraph. So how to avoid this is another question that I want to briefly discuss. A bit more in depth, and I'm happy that I conducted extensive performance measurements before because this would be too embarrassing when Michael Kay told us yesterday you need to measure and to profile and I did this and it revealed certain interesting properties of the method that I'm going to present, also unexpected for me. because the question arose on XSL list when I was dealing with the page break splitting scenario 4 or 5 years ago. The question arose whether this solution is also streamable. Spoiler, it isn't. But a more interesting question in terms of XSLT3 feature applicability is whether we can build a generic solution that splits docbook and JATS and TI and HTML, only configured by 3 or so XPath expressions for selecting the splitting points, etc. So, and this is really an interesting outcome of my research for this paper. So let's start with Elliot's. We will briefly look into Elliot's presentation.
It's exactly the same XSLT document. Right? So, how do you do this? So, this really nice guy, Gerrit in Germany, I don't know how to pronounce. I posted on the XSL mailing list, I have this problem, I want to see a good way to solve it because, I'm a great guy, but I'm not that way. And Gerrit said, here, this is the solution. I'm like, cool. And the basic approach is that he uses a for-each group to split the original tree at the marker element boundaries. And so basically, you get the nodes before the start marker, you get the nodes after the start marker. Anything that isn't in those two groups must be between the markers, and then you construct new trees, one for each set of nodes. And then let's see this here as well. So I have to confess that I don't actually know how it works. This is from...
Yeah, okay. So I'm here to help. So this is the original problem. So you have these embedded 2-column start, 2-column end, and he wants to have 3 separate outer blocks. I will, well, this problem involves nested for each group, and let's maybe start with a easier approach that pertains to the page breaks in the TI. It has a single grouping, and this was raised by Gert Bormans on XSL list. And in the course of this thread on XSL list, there was a discussion about streamability and so on. So he essentially wanted to have a page break at arbitrary depth, split the thing into distinct sections. The example, so it's an overlapping markup problem. You want to kind of invert the nesting. You have the document hierarchy and you have the page sequence. These are different incompatible structures. You can't represent that so nicely in XML, and therefore people always revert to these milestone elements, so signify where a new page starts. I was looking for some test data, and I found the first Bible translation by Martin Luther, which was published originally in 1522, and then in 2017 as TIP5 with embedded page breaks. So it has 452 page breaks at several distinct locations, sometimes in the middle of a paragraph, sometimes between paragraphs, sometimes between topmost sections, sometimes between lower level sections, and so on. Sometimes in the front meta, yeah, these are the occurrences. Hans-Jürgen, I used xQuery for getting this statistic. So this is how the TI looks inside. So we are at page 139, and these facts attributes link to the images of the pages, the facsimile images. And well, this is in the middle of some mixed content, the page break here. You see, oops, what did I do? Okay. If we look here at the, I hope it's legible. So we are in the text below TI, body, div, another div, a paragraph, and then the page break. So it's quite deep in the document. And I made a simplified image of the document structure. The bubbles here are text nodes, and these are the page breaks. So they are at different levels. And now the approach involves selecting all leaf nodes first. So leaf nodes are here, nodes without children, text nodes, or empty elements. So going from, well, when processing it, we start here, but then we stop here and we select all the leaf nodes, and then we group them. You might guess where we will group them at the page breaks. So each PB element starts a new page. And then we have these 5 groups. We have the first group without a page break before, then this one, this one, this one, and this one. And now comes the upward projection part, where the name that I gave the method derives from. I first present 2 slides with the complete XSLT code for this approach. So what we are doing here in the context of text, we select all leaf nodes, and then we group starting with PB. And then we process the top level element in another mode, and we pass a tunneled parameter to that template, or to the templates that process it. And this contains the current group, so starting with PB and all the text nodes and whatever empty nodes there are, and projecting upwards, so selecting all their ancestors and the leaf nodes themselves. So this is, and the name implies this is the restriction that we want to apply to the tree. And then we, for each group, so 5 times in this case, we will process the top level element again with this restriction. And the tunneled parameter will be picked up by what I call conditional identity template in this split mode, and it will simply check whether the given node, remember we processed the whole tree starting from the top level TEI element, and it will, for each element and each text node, etc., will check whether this given node is contained in that restricted to parameter, which for each group is the upward projection. And if it doesn't, it simply doesn't emit anything, and if it does, it invokes the next match, which would be an ordinary identity template. So for the first group, it would look like this. So you can imagine this, what is that pale green here is the future target chunk. So it's the reduced representation. Or for the second one, it's this. So you see here, this is the first leaf node, these are the others. And then if you look, these are all the ancestors right until here. And in the final chunk for this page, it is then restricted to what is red here, or what is kind of greenish here, yellow. And the fifth group would be this. So there's some repetition among the groups, which is clear. I mean, this div is a common ancestor of what is here and what is there. Yeah, but this is intended. I mean, they want to reproduce the exact document hierarchy up to this page break and then start with the page content. And after applying this, the spot that we looked at before, that was in the middle of some mixed content, it doesn't have much content before it. So a paragraph starts. It was in a paragraph before, so this path hasn't changed. All the top level structure has been reconstructed. But everything that came before or after is discarded. Yeah, this is how the method works. I think when looking at these pictures, it becomes clear, and maybe Elliot will watch this presentation later at YouTube and then see how this works. It's not that complicated, but still, when you just abstractly describe it, it's maybe a bit abstract. One thing I forgot, you also have the same problem when splitting HTML. There's in HTML the head element that's not an ancestor of any content. Then if you split the body, and you somehow need to reinsert it. So remember, we were processing the TEI top-level element and in split mode, and when we match the TEI header, we just copy it verbatim. Yeah, the other thing, FO block splitting, it's in the paper. You can read it. It's just, or the code is also linked to in the paper. It's in a repository. You just have the nested for each group. And for the split at line breaks and avoiding splitting embedded footnotes, you need to modify the leaf selection XPath so that footnotes in the first place will look like leaf nodes too, or lists embedded. And the footnote content, the paragraphs, will then be processed in the initial mode where splitting then occurs recursively. This is also described in the paper. So we have this count of page breaks and these nodes, and I thought that the dependence would scale with document size, which turns out to be true. But I also thought it would scale proportionally to the number of split points, which is not true. So I made experiments. I just created, using the upward projection method, a modified one, I created shorter files, shorter documents limited to 375 or to 300 to 200 pages, and then measured the execution time using a reasonable repeat value in Saxon. And averaging above over the runs. And it's approximately linear with document length. In the beginning, it's a bit faster because the first pages, I mean, the constant chunk length here is not exactly true. Each page has its own length, and the front meta pages tend to be a bit shorter. But dependence on number of splitting points, this hypothesis couldn't be justified or corroborated. So when I created these documents for the previous measurements, cutting off at 10 or 50 pages, I noticed that the performance would deteriorate with a large page number, going from milliseconds to minutes. So I thought, let's make another series of measurements, keeping the document length constant, so everything the same, except for removing every other page break. So we started with 450, and then I removed every other, and for the next file, I removed every other PB until I received at only 4 remaining page breaks corresponding to longer chunks. And I saw, and if we choose a different display, not the number of chunks on this axis, but the chunk length in terms of leaf nodes per chunk, then we see it grows linearly with chunk length, at least in this region. Here there are other effects that stem from, well, the number of splitting points, so they have a small effect, but it's almost negligible. So you have that linear range here, and I started profiling it and noticed that this conditional identity template is being called about the same amount of times independent of chunk length, but the runtime for each invocation grew to insane amounts. I thought that this comparison, whether this conditional identity template, where I check, is the current node contained in this restricted to set of nodes, is rather inefficient, and I could speed that up by, instead of using this, just using generated IDs to compare, and I could accelerate at least for Saxon 9.9, the thing for large chunks by a factor of approximately 20, which is quite good. And then for normal documents, we are in a range of more milliseconds to seconds for independent of chunk length, so it won't be too long for real-life applications. The next thing is streaming, and I think Michael K's answer is from 2014 on that mailing list, and I think it still holds true. This method is intrinsically not suited for streaming, and even if it were, the increasing runtime with chunk length would probably make it unattractive for streaming scenarios where you usually deal with large chunks. So no streaming. But as I said, XPath evaluation is quite interesting. And another interesting thing that we got with XSLT3 are packages. And previously, we're using this method since 2010 already. When we import the template rules, there's no one holding us back from overriding templates, and this makes the solution for one splitting scenario maybe unsuitable for the other, so it wasn't really reusable. And the declaring some entry point templates final and hiding the internal templates from importing or from, how do you call that if you use a package? From package using style sheets is really promising. I think it's a really good application and showcase for this package feature, and also, of course, for dynamic evaluation, because it just works and it doesn't run prohibitively long. So let's say in my measurements 1.5 to 2 times as long, and this is acceptable. If you always split docbook at the same milestone elements, then you will probably create a bespoke solution, but for general case, for experimenting with unknown data, you just can pass 3 XPath expressions and split at these arbitrary positions. So finally, XSLT really pays off. Elliot Kimber, a week after I sent him that solution on XSL list, sent me this really precious bottle of scotch. So it's XSLT for fun and profit and several other things. Thank you.
We have a few minutes for a question. Yes, over there. Is there anyone else?
Yeah, thank you. Michael Müller-Hillebrand from Docify. We are creator of a content management system. I want to say a big thank you. I was watching the conversation of XSL list, and we use it to split FO page sequences. And it made me aware, this solution, by reading the intersect operator, that we are dealing with set theory in some kind of. And from hearing that this is kind of a performance stumbling block, and the generate ID things kind of, to me, looks like retro uncool. Maybe this is an opportunity to, we don't have a performance problem with this. We usually kind of have 2, 3, or 4 splitting points in a FO document, so that is not an issue, but I'll tend to leave the intersect in the code because it's way more cooler to read like dot intersect something in forms of teaching colleagues how all this stuff works instead of this generate ID thing. And maybe there is room for some optimization in the processor of our choice.
Yeah, I would say so. This is accidental limitation of Saxon, or maybe not so accidental, but another processor could be even more inefficient with generate ID. And I think you were the one who was asking for streaming in 2014. You, Michael. Let's check that. So, yeah, but this is the bad news. Streaming won't work. Yeah. Abel. No? Okay.
Tony Graham from Antenna House. I'll just point out that Antenna House can do nested page sequences. So you might not need all of this for page sequences.
Yeah, wait, no, there doesn't come an answer there? Okay, anyway, I'm not 100% sure I totally understand the problem why it couldn't be transformed into a streamable way. But, wait, better? Sorry. But it looked to me like you were accumulating data with the tunneled parameters, and to get that into some kind of streamable fashion, you might be able to use streamable accumulators. Have you attempted that, or?
I haven't attempted. I thought about it, but I'm not experienced enough with streaming, and I suggest that you ask your immediate neighbor what he thinks about your suggestion, because as I said, I don't know, but I thought, okay, if we have that downward selection and then start again processing from the beginning, it could be problematic. I looked at accumulators and thought, okay, no, these are. I wasn't sure whether I could accumulate all my generated IDs or whatever I need there. So.
I could have a look.
Yeah, sure. I mean, the code is in the repo. Maybe you want to also have a look, because streaming is not that,
Simple?
Yeah.
No other question?
Okay.
Okay, thank you very much. So now we know that we can